Hi everyone and welcome to the first episode of the EST series wherein we try to solve various problems on EST. For this video, we will be answering questions regarding antenna and microwave link. Okay, so for our first problem, Engineer Juan de la Cruz wants to establish a radio link between point A and B approximately 75 miles apart. Assuming that the path is unobstructed and the height of the antenna for point A is about 750 feet above sea level, how high should his antenna be at point B to establish a good radio communication link? Okay, so we have here the transmitter antenna and a receiver antenna. And these antennas are respectively located at points A and B. And sabi sa problem, the distance between these two is 75 miles. And aside from that, we are also given the height of the antenna for point A, which is about 750 feet. So again, natin yung 750 feet. Okay, so we are not given the height of the antenna at point B, so lagyan natin yung X. Please do not convert anything sa problem na to. Instead, mamimili po tayo sa dalawang formulas na isusulat natin ngayon. So, alin sa dalawang formula ang gagamitin mo? So, it all depends sa unit na ibibigay sa'yo sa problem. If yung distance mo is in miles and yung height mo is in feet, the formula that you will use is this. D is equal to 2 times the height of the transmitter in feet, get the square root, plus 2 times the height of the receiver in feet and get the square root as well. On the other hand, kapag naman ang binigay sa'yo na distance is in kilometers and yung height is in meters, ganun din yung format, maiiba lang yung value. So, D in kilometers equal to 17 times the height of the transmitter in meters, then get the square root, plus 17, then height ng receiver in meters, then get the square root as well. Now, for this problem, we will use the first one, which is in miles, and the height is in feet. Okay? So, plug lang natin yung value. 75 is equal to 2 times 750. Then, kunin natin yung square root plus 2 times X. So, yung X variable, ito yung height ng receiver. So, shift solve lang natin yan sa calculator. Ayan. And so, therefore, yung height ng ating receiver pala is 657.76 feet. Okay. So, makikita nyo, hindi sila same ng height. Okay, so for our next problem, when a typhoon hit Quezon, physical antenna misalignments were evident which affected the signal performance in the province. Calculate the polarization mismatch loss in decibel between the two antennas for an angle of 15 degrees. Usually, nangyayari talaga ito sa Philippines since madalas matamaan ng bagyo ang ating country. Now, most of our antennas follow what we call as the line of sight propagation or the LOS, wherein the main goal of the transmitter antenna is to transmit or propagate the signal directly to the receiver. Kapag nagkaroon ng alteration sa orientation ng ating antenna, maapektuhan ang ating line of sight propagation and therefore, it will also affect what we call as the maximum power transfer between the transmitter and the receiver and thus affecting our signal performance. Anyway, whenever we encounter these type of problems, we simply place the value of the angle on our formula. By the way, you can make some further readings on this topic by checking out this link. Okay, so kuhain na natin yung ating calculator. And so, pinitin lang natin yung logarithm. And by the way, it's 20 logarithm nga pala. 20 logarithm. Yan. So, may parentheses yan kapag pinitin nyo yan. So, be careful with your parentheses. Cosine 15. And you will get an answer of negative 0.3011. So, there are cases na ang ibibigay sa choices is simply 0.3011 and hindi nakalagay yung negative sign. This is because naka-indicate na naman sa problem na it's a mismatch loss. Okay, so yung negative sign kasi dyan, it means that it's a loss. Okay, so may loss tayo sa ating signal. So, therefore, since nakalagay na naman sa ating problem na it's already a loss, we can eliminate the negative sign and stick with 0.3011 dB. Okay, so for our next item, A 275 feet high transmitting antenna has a gain of 12 decibel over a dipole. The receiving antenna, which is 60 feet high, has a gain of 3 decibel. The transmitter power is 100 watts at 224 megahertz. Calculate A, the maximum transmitting distance, and B, the received power at the distance calculated in part A. Okay, so before natin to solve, may ilalagay lang ako ditong note, like super quick lang. So it's a conversion from miles to kilometers. In the first part, we are asked to get the maximum transmitting distance or simply the distance between the transmitter and the receiver. Ano bang binigay sa atin? We already have the height of the transmitting antenna, which is 275 feet, and the height of the receiving antenna, which is 60 feet. Okay, so just like kanina, since pares naman sila naka-feet, ilalagay lang natin sila sa ating formula. The distance in miles equal to 2 times the height of the transmitter in feet, get the square root, plus 2 times the height of the receiver in feet, and then get the square root. And then plug lang natin yung mga values dito. Okay, so 2 times 275, get the square root, plus 2 times 60, get the square root. We should get square root of 550 and square root of 120. So we will get an answer of 34.4 miles. So kung wala dyan si B, I think we're okay with 34.4 miles na. But since we have a second part for this problem, I'll decide to convert it to meters pa, just so we can answer correctly the problem in B. Okay? So 34.4 miles. So, i-convert natin siya into meters. So, we will use this conversion, which I wrote earlier. So, 1 mile is equivalent to 1.61 kilometers, and 1 kilometer is equivalent to 1,000 meters. Okay, cancel lang natin yung similar units. And we would get an answer of, kay Frenzel, pag yung tingnan nyo kay Frenzel, ang sagot niya is 55,400 meters. But, if you're going to use your calculator, you will arrive at an answer of 55,384 meters. But for this video, we will use the latter, which is 55,384 meters. And by the way, you can already store this value to A para mas madali siyang i-plug in sa calculator mamaya. For those of you who do not know how to store the values in your calculator, ganito lang siya. Okay, so Shift, Store, then pili lang kayo ng any variable. But since A yung ating pipiliin, yan, lagyan natin siya sa A. So, makikita niyo yung A by pressing this button. Okay, yung may dalawang parentheses. Okay, so for the second part of this problem, so we are asked to get the received power. And for that, we will have a designated formula. Okay, so for the received power, our formula is the power transmitted times the gain of the transmitter times the gain of the receiver times lambda squared all over 16 times pi squared times distance squared, wherein the distance must be in meters. Okay, kaya pala natin kinonvert yung sagot kanina to meters kasi yung formula dito is naka-meters. Okay, so let's proceed. Ano ba yung mga binigay sa ating values? So it's already indicated in this problem na ang transmitter power pala natin is 100 watts. For the gain of the transmitter, we have 12 decibel. However, pag yan ang kinonsider mo, magkakamali ka since hindi mo kinonsider yung phrase na over a dipole. Kapag nakikita ka ng over a dipole, you have to add 2.15 decibel always. Therefore, ang gain pala ng ating transmitter is 12 decibel plus 2.15 decibel. And that will give you an answer of 14.15 decibel. Yan na bang ilalagay natin? Hindi. Bakit? Kasi yung gain ng transmitter and gain ng receiver, kapag ang hinahanap natin is yung received power, must always be unitless. So, paano natin siya i-convert to a unitless value? So, kukunin lang natin yung antilog niya. Okay? So, paano kumuha ng antilog? So, shift log. Okay, lalabas dyan is 10. So, press ka lang ng exponent. Then, ilagay mo sa numerator is 14.15 over 10. And you will get 26. And that will be your gain for the transmitter. So, lagyan lang muna natin dito ng annotation yung ating mga final values. So, for the gain of the receiving antenna, we have here 3 decibel plus 2.15 decibel. And we will get 5.15 decibel. Similarly, we will convert it to a unitless value, and we will have an answer of 3.27. Okay, so meron na tayong transmitted power, the gain of the transmitter, and the gain of the receiver. And we will store these values to B, to C, and to D respectively para madali natin siyang i-plug mamaya sa calculator. Okay, so lastly, we will solve for the wavelength. So we all know that the formula for the wavelength is the velocity of light divided by the frequency. So we have here the 3 times 10 raised to 8 divided by 224 megahertz. Ayan. So we will have an answer of 1.34 meters. Stored lang natin siya sa E. So with all the values considered and solved, let's plug it in our calculator. Kaya ako pinastore sa inyo kanina yung mga values para madali siyang i-plug in sa inyong calculator. Kasi nga kapag board exam, ang kalaban nyo lagi dyan is yung oras. And with that, we will arrive at the answer of 31.516 nanowatts or 31.516 times 10 raised to the negative 9 watts. And for our last problem, we have here an objective type of question. In order to have a maximum power transfer between a transmitter and a receiver, both antennas must have the following characteristics except kung binasa nyo kanina yung picture na pinakita ko, masasagot nyo to. Okay? So the answer for this question is A, the height. So you can do some further readings on this topic by checking out this link. Ayan. So sinabi dito that in order to transfer maximum power between a transmitter and a receiver antenna, both antennas must have the same spatial orientation, the same polarization sense, and the same axial ratio. So hindi nabanggit sa paragraph na to yung height, and therefore height is the answer. And that is it for this video. If you guys are down to this type of content, feel free to comment the topics or questions that you want to include on this series, and I will try to answer it on my next video. Or if you want a part 2 of this episode, just let me know. Thank you so much for watching, and I'll see you on my next video. Bye!